of the sun. And we are going to record this session if you don't mind. Please let us know if you do, because this way then we can share it with everyone that were not available at this time, and they can also share a bit and profit from the knowledges and your questions and information on the sun that will be shared afterwards. Does anyone has anything to do against it? Okay, do you all agree? Okay, great, thank you. So welcome everyone. As I was saying, I'm Lina Silveira from FCSS. We manage the communication in Sun's network project. It's a H2020 project. And we'll have an agenda that includes our keynote speaker, Jorge Pereira from EUROCONTROL. And the keynote presentation he will be giving you today is Use, Evolution and Opportunities of Space Technology in the Global Aviation Context. After that, we'll have space for some Q&A, and then it will be the presentation from Goda Civic from Sun Project, and it includes also Q&A, and you will know more about how can you participate in Space Hub Network, that we also call Sun, in a way that you can also have support for your space technology startup or scale up. And Goda is representing Civita in the project. So then we'll have the short closing remark, and hopefully we'll continue to have you following us up in our LinkedIn, in your Twitter, and we'll keep going with you following our work. So for now, I wanted to present Jorge Pereira. He's the head of the CNS, and he's going to present you today, as I said, this subject that I'm sure that will be of the interest of many of you, and transversely is connected with the space technologies also. So Jorge, please take the floor. You're unmuted. You're muted, sorry.
Thank you, Lina. Okay, good morning, everybody. It is a pleasure to try to increase your awareness on how the aviation is using space technologies. So I put together a number of slides where I try to recall how space technologies are used in the context of aviation, and also trying to highlight what are the, let's say, the technology challenges that we try to address at the moment. So to set the scene, let's have a look at the current flight level. So last week we had around a bit less than 20,000 flights a day, and you see the main hubs in Europe. You see that the traffic levels are a bit, let's say, lagging behind the levels of 2019, the pre-COVID situation. So we have around 70%, 75% of the traffic levels that you used to have in 2019. So we can say that at the moment we are catching up, in fact, and we expect that when the COVID slows down, we will approach levels of 2019, where we used to have close to 30,000 flights a day. So I'm convinced, I'm optimistic, I'm convinced that gradually the flight levels will increase. And these numbers, I'm not sure if you have the perception, but these numbers say that we have traffic congestion in Europe, in fact. So
sorry, George, just
yeah, sorry, yeah.
I'm sorry, we don't see your slides. Were we supposed to see your slides?
The slide is, you see this one?
No, we're not seeing the slides. I'm sorry. I thought you were still introducing yourself, but then it's
okay. Then I need to maybe to end the slideshow and to try again. What about now? Well, you
still.
hear me, right? And do you
Yes.
see any slides now?
No, we cannot see. Maybe, Christiana, you have ended your share
Hold on.
screen, right?
Yes, I ended.
I'm
Hold
sorry
on.
for this technical
Yeah.
issue, but
I
we'll resolve
try.
it.
So I share my presentation again. Hold on. I try to share my presentation
We
again.
tested before you enter, all of you, and it worked.
Now it's
It
working.
Yeah.
worked now. Yes,
Good.
perfect,
Are you
George.
able to see something now?
Yes, it's
So
perfect now. Thank you.
go in mode. Let me see. Is it there now?
Almost, just a minute. For now,
Yeah, I know what happens. The network is rather slow. And
yes,
now I move to the next slide. Do you see something?
no, we just see without
Oh, yeah.
slideshow mode.
So what I would suggest is that you share the slides yourself,
Okay.
because the network is rather slow here, you know.
Okay.
So I end.
Okay, let me just.
I stop sharing
1 minute, please.
the slides, and you should share them.
Now
yourself.
it's working. Now it's
now
working.
it's working.
Now it's working. It's perfect now. You can go.
Okay, very good. So you see this slide, right?
Yes, perfectly.
So this is the slide where I try to present the current air traffic levels, numbers of flights in one day. And I was saying that we have around 20,000 flights a day, and we are slowly reaching same flight levels as 2019. And due to COVID, for sure, we are 25% below at the moment. In any case, we have some predictions that show that in one day in 2030, we may have 58,000 flights. So 58,000 flights in one day in Europe is really huge congestion, and this will have strong implications in terms of flight efficiency, in terms of environmental impact, delays, costs, safety, everything. So we concluded some time ago that the aviation system, the aviation infrastructure needs to evolve, needs to be modernized to cope with these levels of traffic, because the infrastructure that we use today is not is not suitable to support these levels of air traffic. And the plan to modernize the aviation infrastructure, the global infrastructure, in fact, has been defined by ICAO, so the worldwide organization managing aviation business, and in Europe, the so-called European ATM Master Plan, which is a document normally approved by the EU Council, the EU Parliament. So we have a plan to modernize the infrastructure. And in fact, this modernization will introduce higher levels of connectivity, higher levels of automation, and it introduces a number of new concepts, including the so-called trajectory-based operations, and performance-based navigation, new separation modes, and so on. And these new concepts, in fact, they will enable higher levels of flight efficiency. And this is what we need to address traffic congestion, to address also the environmental challenges, reduction of CO2 emissions, as well as higher levels of safety, and to rationalize the system, reducing the cost. Now, the use of space-based technologies is a fundamental enabler for this aviation system modernization, and space-based technologies will be used in the context of communications. In fact, to enhance communications between the cockpit and the ground systems, supporting the so-called communications between the pilot and the controllers. We call this CPDLC, Controller Pilot Data Link Communications. trajectory management is a fundamental function. So the ability to manage in real time the trajectories that are flown. And in the navigation domain, satellite technologies will support so-called performance-based navigation. It's a new concept that is being introduced. We introduce, let's say, more efficient landing systems, and for the trajectory management operations also supported by the navigation enablers. And then in terms of surveillance, what we call surveillance, we will have, it's already operational, a system that is able to track the position of all flights at global level. And on your right-hand side, we make a reference to the satellite constellations that are supposed to be used. So for communications, we basically use Inmarsat constellation and Iridium. And for navigation, we use GPS, and we are now introducing Galileo, European constellation. But the Russian GLONASS is also an option in this respect. Then we have so-called augmentation systems that I will describe later on. And then for surveillance, it's basically Aeron. It's let's say a service that is now in place, supported by Iridium Next constellation. I will say more about that. So I start with the trajectory-based operations. So this is a new concept, and the objective is simply to increase the longitudinal performance of the flights. So we already have, let's say, reduced separation in the vertical dimension and in the horizontal dimension. And now we try to add in aviation, let's say, improvements in the longitudinal dimension. And this is done by exchanging the so-called time constraints between ground systems and the cockpit. So it means, in simple words, the ability for the aircraft to meet a time window when it crosses a waypoint along the route. And this is, let's say, normally synchronized with the airports. So the airports need one landing every 30 seconds. So the main hubs in Europe, like Heathrow, Frankfurt, Charles de Gaulle in Paris, we have one landing every 30 seconds. So you imagine that we can, let's say, sequence the traffic in a way that we are sure that we have one landing respecting these time constraints. So this is what we call trajectory-based operations, and it requires communication between the cockpit and the ground to exchange in real time this trajectory data. And this requires, let's say, air-ground communications, and we call this in aviation data link. And today we're still using voice, air-ground voice communication. So the pilots, they speak with controllers on the ground using VHF radio communications. And we are now introducing, or we have already an operational service, a data link, a terrestrial data link system between the cockpit and the air traffic controller on the ground, relying on so-called ATN video mode 2 technology. So it's a legacy technology that is has lots of limitations in terms of the data rates and the bandwidth. And because of that, we are planning to introduce 3 new technologies. It will comprise a data link for the airport environment, a terrestrial data link, so-called LDAX, and SATCOM. And this is where I will focus my presentation. And these things are, let's say, not yet operational, but there are plans to introduce those technologies in the short term. And the fundamental aspect is then to interconnect the aircraft computers, the so-called flight management system, with the ground air traffic control systems to support what I described before, trajectory management. So you can see the roadmap defined by ICAO, which will guide this introduction. And we will have, well, this SATCOM is this layer here, and we will evolve with some initial SATCOM services already standardized by ICAO to let's say, the so-called Class A SATCOM, where you can say an aircraft it will be an IP address of a network and fully connected to the ground environment. And then you can see here the VHF terrestrial systems and the systems for the airport. Now, the technologies that are already in place to support the communication, the SATCOM communications between aircraft and the ground, comprise, I would describe three. These are two constellations only, but IRIS is something specific that I will describe later on. So the first constellation is Inmarsat, and Inmarsat is a constellation of 13 satellites. So with high Earth orbits, they are geosynchronous satellites. Only 4 satellites are used at the time, but the full constellation comprises 13 satellites. And Inmarsat is being modernized, and we call this modernization the Swift broadband. And it supports a wide range of services that include the in-flight experience for the passengers. So the passengers, they can connect themselves to public internet to have web browsing and these kind of applications. And there are some services to connect the cockpit to the airline operations. But then the air traffic control, safety of life services are still limited in the continental airspace, but used since 40, 50 years now in the oceanic environment, where we exchange today around 50 million messages a day for the oceanic separation, position reporting, and all that. Inmarsat comprises, well, the I4 segment was launched since 2008, and I6 will be fully operational in 2023, and there are launches happening in plan for 2023 as well. So this is Inmarsat. IRIS is, let's say, the specific project to use Inmarsat for air traffic management, and is led by the European Space Agency and involving some industry, including Airbus, Honeywell, and other companies. And it's about to reach full operational capability in 2023 as well. And there were trials. We call those trials the precursor trials, which took place in 2018. And then the second constellation is a very old constellation, used to belong to Motorola, then the US DoD, and it is now in place. It's Iridium. It provides a global, worldwide constellation. Full coverage is a low Earth orbit system comprising 66 satellites, and it supports, again, a wide range of services, ranging from, let's say, flight deck web experience for the passengers to some level of global tracking service that I will describe later on. And all these systems, they are subject of ICAO standardization. So you will see that in aviation, we have a very specific safety-driven standardization system, and this sometimes creates a situation where we have technology cycles that are not consistent with other domains, other technology domains. So I would say that aviation technology cycles are slower than the telecommunications technology cycles, for example. So this is just describing how Inmarsat is used. So we have, let's say, the services available to the passengers, the services supporting airline communications, and then the cockpit air traffic control services, still a bit limited and dependent on the standardization, let's say, activities within ICAO. IRIS, so the specific project for air traffic management using Inmarsat. You can see there the status of the activities described, and I will highlight here only that Q2 2023, this service will be fully operational to support a wide range of services. And Iridium Next, so some more details there. I would highlight here that we have a security functionality in Iridium Next, so the modernization of Iridium. SpaceX is launching satellites, Iridium satellites, and there were 40 satellites launched in 2017, and these launches continue. And it will support, again, a wide range of services for passengers, for the airlines, and also something for, let's say, air traffic control, including the global tracking that I will describe later on. Now, this was the use of space technologies for communications. Now let's speak about navigation. Navigation is all about the performance of the aircraft to be able to, let's say, to meet certain integrity requirements and some separation levels between parallel routes in the vertical, in the horizontal, and in longitudinal plane. And the new concept to support that, to make navigation more efficient, is what we call performance-based navigation. And it is fully described in the ICAO document 9613. And it consists in, well, it will be the basis to improve the airspace structures, the procedures that are published to support flights. And it relies strongly in what we call global navigation satellite services, which is a collective designation for multiple satellite constellations. And it will enable us, in fact, basically to accommodate more flights in the same volume of airspace. And it is, let's say, an evolution from the so-called conventional navigation. And in conventional navigation, there was a need to overfly ground-based navigation systems, and with performance-based navigation, that is, let's say, the freedom to fly wherever we want, provided that there is a certain coverage of the navigation system. And this requires then a more complex avionics, including a specific computer on board the aircraft, and then a number of sensors that can include satellite-based receivers, but also, let's say, connection to the ground infrastructure, the distance measuring equipment, inertial navigation systems, and VHF omnidirectional range systems. So performance-based navigation is somehow decoupled from the infrastructure because you can use different means to support navigation. And so far, we have been using mainly GPS L1 frequency, but we are migrating to use multiple constellations and multiple frequencies at the same time with one single common receiver. And this is what we call multi-frequency, multi-constellation. The introduction of performance-based navigation in the European airspace has been regulated by the European Commission. And a fundamental aspect is that for navigation, you cannot use signals in space in isolation. You need to correct these signals, and this is what we call augmentation. So it's you have a constellation of satellites, and then you need a second constellation to perform the differential correction of those signals in order for them to be performant enough and to have sufficient levels of integrity for navigation. This is just a picture showing the increase, let's say, performance that we have when we move from conventional navigation to area navigation. We call it RNAV, or required navigation performance. And there you can, let's say, we have routes that you can choose your trajectory, not being, let's say, constrained by the ground navigation infrastructure. So as I said, satellite systems can be jammed, can be are vulnerable to solar activity. They can be, you can have outages. So you have very often you have outages, and the pilots report when they lose the GPS service. And because of that, we need to have backup. So we need to have a ground backup, terrestrial navigation system in place. And then the signals from space themselves, they need to be corrected. And then on top of the, let's say, the core constellation, and here normally we consider GPS, a Galileo that is already, the service is about to be completed now, and GLONASS. And in GPS uses 31 satellites, with some spare, so 27 satellites, 2 frequencies, L1 and L5. And the latest launches of GPS satellites took place in 2017. And GLONASS is a Russian constellation that comprises 24 satellites. And we have also the European Union constellation comprising 24 satellites, medium Earth orbit, and the last launch took place on the 5th of December 2021 for Galileo. So these are the, let's say, the core constellations, and we have been working in aviation to specify a receiver that can receive, let's say, can work with the different constellations on different frequencies at the same time. And then we have 3 kinds of differential correction systems. We have aircraft-based augmentation system, space-based augmentation system, and ground-based augmentation system. So the aircraft-based augmentation system is only, let's say, a technical solution that alerts the pilot that is losing the performance. A space-based augmentation system is another constellation that, let's say, corrects the original signal from space. And in Europe, you have the EGNOS, the European Geostationary Navigation Overlay System. It's a system that is providing a significant number of navigation services, not only for the en route, but also for the airport, the approach and the airport domain. And similar systems exist around the world. The WAS in US, the MSAS in Japan, GAGAN in India, and others. And then finally, you have the ground-based augmentation system. It's on the runway ends of airports. It's you have a ground station, normally using VHF, that corrects the signals from space, and it's used to support so-called precision approaches. That when the aircraft land, they rely on this system, and it's gradually replacing, let's say, another system called the instrument landing system. So this is these are the augmentations, and satellite systems used for navigation. This slide describes a bit where we are at the moment. So ICAO continues to publish, let's say, SARPs, which are the standards and recommended practices, are the standards that, let's say, approve, let's say, the use of a certain technology, and they focus now on the use of additional constellations and not only GPS with 1 frequency. And the aircraft-based augmentation system, advanced RAIM, is also being standardized at the level of ICAO. So lots of activities at the level of ICAO. And a second area where we pay lots of attention, and it consumes lots of effort from our side here in EUROCONTROL, is the radio frequency interference. So we try to identify the areas where we have, well, the GPS and GNSS signals are jammed, and where the service is lost. And typically in the Middle East, we have lots of problems. So we have let's say, an activity in EUROCONTROL to deal with that. And we try to address the specific needs of the military as well, because there are governmental signals that are more robust, and we try to identify a methodology for them to be usable for performance-based navigation as well. Now, the next, the surveillance domain. In the surveillance domain, we also using space-based technologies, and this we have a system in place that relies on the Iridium NEXT constellation, and this was introduced in the sequence of the Malaysia Airlines flight MH370 that disappeared in the Indic Ocean in 2014. And after that, we decided that in 70% of the airspace on Earth, we didn't have surveillance. We didn't have radar systems. So it's over the oceans and in the deserts or remote regions. And we needed to have a global system where you can track the position of the aircraft wherever we are. And for that purpose, some Iridium satellites, they were equipped with automatic dependent surveillance broadcasts. These are some transponders that receive broadcast transmissions from the cockpit, and they retransmit that to the ground. And the Iridium service is now operational. It belongs to Iridium Communications Company, NAV Canada, the Irish air navigation service provider, the Italian, UK, and some others. So they created a consortium, and they are now providing this service. So it is in place, and it provides not only global tracking surveillance, but also lots of data that is used. Here in EUROCONTROL, we use a lot data on, let's say, the traffic levels and to identify the areas where we have congestion. So Iridium NEXT satellites that support Iridium, this is the Iridium system, they represent really a huge added value for aviation. So just to summarize the main issues. So we are at the moment, we are moving away from voice to data exchanges between the aircraft and the ground. And the aircraft need to be connected to the ground to support, let's say, clearances, the communication, routine communications between the pilot and the controllers on the ground, but also to support trajectory management, which is a fundamental concept to increase flight efficiency. And the data link services that support this connectivity between the aircraft and the ground, they are in place in Europe, but using a legacy technology. And we know that, let's say, more advanced technologies that offer something close to 1 megabit per second and higher levels of bandwidth are being introduced in the global context, but also in the European context. And for communications, we rely mainly on Inmarsat Swift broadband in Iris and Iridium NEXT. We also use space technologies for navigation, and there the fundamental concept is performance-based navigation, and it's a kind of priority for ICO. But knowing that this satellite, the GNSS satellite-based systems, they require a terrestrial backup. We call that alternative position navigation timing, and we will retain, let's say, the DME, the distance measure equipment, and other ground nav aids, because we need to mitigate the situations where there are GNSS jamming and outages. We perform here in the EUROCONTROL as network manager the GNSS monitoring. So we monitor the situations where we have loss of GNSS service. And I just described a few minutes ago the Iridium global tracking infrastructure that is now service that is now in place, offering, let's say, the possibility to determine the position of all flights at global level. Just one final remark, saying that the future system will be performance-based. So it means we are not, let's say, we are moving away from the equipment-based approach, and we now define what are the levels of performance and service that we require, and then we accept that different equipment or different infrastructure elements can support these services. A final word on military aspects. So here we cover the civil military interoperability aspects. And the military, they use their own technologies in the satellite. In terms of satellite technologies, the focus of the military goes to the security requirements and the higher levels of precision. And we are trying to, let's say, to define solutions for the military to be able to use their own technologies to support the same services as I have described for civil aviation. So it means there's a number of specific military technologies that are to be considered in this context, and this includes governmental SATCOM, the restricted signals, the restricted GNSS signals, and TACAN, for example, which is a terrestrial navigation system used by the military. So you have, in the EUROCONTROL website, we published 2 years ago a document that describes, let's say, the civil military interoperability aspects in detail. And okay, that's it. I apologize for this very specific aviation terminology, but I hope you understood that satellite-based technologies are really important for aviation, and are, let's say, they support higher levels of connectivity and automation that we are introducing in order to meet the challenges related with traffic growth, and also the challenges that that result from there in terms of CO2 burn. So we need to fly at higher levels. We need to have more efficient trajectories and so on. So that's it on my side. I pass you the floor. If there are any questions, I'll be happy to take them. Thank you.
Yes, that's what I wanted to say also. If there are any questions, please let us know in the chat, or simply open your mic, and then Jorge can reply to your questions.
I don't have my chat visible, so I would really appreciate if you can relay any questions to me.
Yes, don't worry. If there is any in the chat, for now, we don't have any in the chat. Okay, now we have Greg Agripoulos that raised his hand. So you can go ahead, please.
You're probably muted.
Yes, Greg, you're not muted, but we cannot hear you. I can see that you have your mic on. Maybe
yeah, most likely are you muted.
I see the symbol.
How about
you are
now?
Okay, now yes.
No. All right. So I have a question regarding a topic that is near what you presented, but a little bit outside. Have you examined how virtual or augmented reality could change the way that air traffic control is performed, or training and maintenance activities in the whole area, and if this is priority, high or low?
So sorry, I didn't understand the final part of your question. You're asking if we have analyzed the air traffic services related with
virtual reality and augmented reality, a new way for controllers to interact with the digital information.
The new way of controllers to interact with, you mean trajectory operations, no?
Yeah, there is a new technology called virtual reality, where the user, or augmented reality, the user can put on some glasses to present the digital information in a different way, faster and with better way. So if you have something in mind about the new way that the controllers do their work, or some other activities.
So basically, you know, in the aviation system, the fundamental aspect is the need to provide what we call a separation service. So the way for the responsibility to separate the traffic, the flights, resides on the ground. So it means the air traffic controllers, they are in permanent contact with the cockpit when they detect any, let's say, deviation. And typically let's say in the core area of Europe, the flights need to be separated 5 miles horizontally and 1 mile vertically. But now, as I explained, they will need to be separated also longitudinally. So it means the computer of the aircraft receives information with the time window, which determines that the aircraft needs to pass at a certain point within that time window, which can be some seconds, you know. And let's say the aircraft transmits this information to the ground in real time, and this information is integrated in the so-called flight data processing system. And the displays that the air traffic controllers have in front of them normally provides information about the exact position of the aircraft, the speed, and the number of what we call state parameters of the aircraft. So the angle, the rate of climb, the rate of descent, or whatever. So and this is the way air traffic control is performed. Now, during the flight, because you have bad weather, or the pilots, they need to avoid a dangerous cloud, a cumulonimbus or whatever. They have voice communications directly with the controller on the ground. And then normally they ask clearances. We call these clearances. So they ask authorization to descend, to climb, to fly around, whatever. And these clearances, we have automated the clearances with kind of an SMS, so predefined text messages that are exchanged between the cockpit and the ground. And this is to alleviate the voice workload.
Yeah.
The pilots, they send these short messages. And this is the data link service we have in place today. But it is limited, as I explained. We have lots of the so-called provider aborts, and we have some technical limitations. So we need the next generation of communication technologies to be implemented, and this is SATCOM is the fundamental option, which is already in place today. So the passengers in many airlines, you can browse, you have access to the public internet. So the passengers are better equipped than the pilots, I would say, because the technology in the cockpit is still from 40 years ago, and the passengers have very nice web browsing in-flight experience. So this means that we have different technologies life cycle for air traffic control, the safety of life applications, than for the telecommunication applications in general. So I don't know if I responded to your question. I tried to describe a bit how air traffic control is organized these days.
Yeah,
Thank you.
actually, I'm aware. Thank you very much for the introduction. The question is about if you are analyzing new technology of displays. That was the major point. So there are some new displays like glasses in the eyes. So if you are analyzing this type of displays, or you know something around that.
Now I finally understood your real question. The display, yeah. No, the displays, the modern aircraft, they are glass cockpit, okay? And you have multifunctional displays. And in fact, when we introduce new concepts, we need to update the displays, in fact. And this is, well, we are now working on we call that the CDTI, Cockpit Display of Traffic Information. We are working on a new system to support air-to-air exchanges as well, the so-called ADS-B, Automatic Dependent Surveillance Broadcast. And this will require one more display. But the displays are software, you know. I am myself, I'm doing some work on the future, the use of software-defined radio technologies for the cockpit. And I work on that, in fact. And it is true that the architecture of the aircraft today, it constrains a little bit some evolution, but we are working on that, yes. And we have a huge program in Europe called CESAR, which is co-funded by the European Commission and us, the EUROCONTROL, and we spend until 2030, we will spend 1.5 billion euros on that. So we are working on that, be sure. Thank you for your question.
No worries. Thank you.
You are
Sorry,
muted, Lina.
It's my turn to be muted. So I have here a question for you from Florian Lipok, he is part of the consortium actually. And he did here a question for you that I will be reading. And I'll be reading the full text actually, because it starts by saying, thank you for the great presentation. And then it says, in what time frame do you see full broadband data transmission between the aircraft and the ground? And how far are we on the path to fully autonomous flight in a technical aspect?
Yeah. Well, the exchange of data between the aircraft and the ground, it happens in the oceanic context. It happens since 40 years ago. And I said that Inmarsat today supports the transmission of 50 million messages a day, okay, in worldwide in the oceanic context, supporting let's say what we call separation applications in the oceanic environment and position reporting. So in the oceanic environment, every 10-15 minutes the cockpit transmits a message with the position, and so the messages data is already being exchanged. I mentioned also these clearances between the pilot and the ground controllers, so we call that CPDLC, and this service is in place. So we are exchanging data messages supporting that. We have four or five applications in place today, and then we will introduce trajectory management. It's not yet there, and when we introduce trajectory management, then we increase the level of automation. There is something we designate air-ground SWIM. SWIM is system-wide information management. So it's just the integration of each flight in a network that is network-centric, and we used to say that in due time each aircraft will be an IP address that flies, which will be part of a network. And then you have data exchanges between the aircraft and the ground, as the same way you have between any ground-based subscriber and a network-centric internet environment. But this is it will not happen tomorrow, not even the day after tomorrow. And I used to say 10 years is the day after tomorrow in aviation. So it means these are things that will happen for 2040 plus. Okay, so long term. And autonomous operations, for us, it means the transfer of separation responsibility from the ground to the cockpit, where, let's say, the pilot will be able to self-separate from the rest of the traffic. So for that requires the air-to-air connectivity and some other technical means that do not exist at the moment. One of those is what I just described, is automatic dependent surveillance broadcast. We call it ADS-B in, with the aircraft able to exchange between themselves. The only interaction between one aircraft and the next one today is a anti-collision airborne collision avoidance system, the so-called TCAS or ACAS, where this is already in place. It exists. So if two aircraft are about to collide, there is an exchange, there is a protocol exchanging data between the two aircraft, and one pilot receives an order to climb and the other one receives an order to descend. This exists, but this is only one specific application. So we are not yet there, and autonomous operations, if ever happens, it will be something for the very long term. And I will be retired at that time. So I will be in Portugal, and then I'll be able to see the sun and to eat fish. So I'll be, it will be not, most likely it will not be my problem, for sure.
George, thank you very much. We just have one last question, but I will ask you the most synthetic answer to it because I have to move on, but I didn't want to interrupt as it's a very dynamic and interesting discussion. Now we have here Bob Jobdik that asks you, are systems like flight radar 24 or flight aware of any usage to you as a source of aviation data?
If the flights are dependent on a source of aviation data.
No, I will repeat. Are
Yeah.
systems like flight radar 24 or flight aware of any usage to you as a source of aviation data?
Yeah, they are being used. They are being used. Although these platforms, you have Global Tracker, Flight Aware, Flight Radar 24. You have a lot of applications. These were, let's say, these are platforms where, let's say, private persons, they simply bought some receivers and they have some home-based, let's say, applications, and they started to publish on internet an air picture, what we call an air picture, in fact. And there are lots of concerns, you know, because certain military flights or certain VIP flights, heads of state, and that are sensitive, all of a sudden, these flights are visible on internet. And this was a real concern. And then I have here some colleagues that we were discussing how to mitigate this problem. So we made agreements with Flight Radar 24 and other providers to filter certain flights. So there are some flights that are not visible because they filter the so-called 24-bit address, which is the unique identification of each aircraft. So they filter some flights, first point. So it's still a bit a threat that some sensitive flights can be visible on internet, but there is some mitigation there with good cooperation from the providers. And then in parallel with that, there are some organizations are using these services as a source of data, and this data is being used for normal aviation business purposes. So it is beneficial to have those services, and these services take advantage of something which is the aircraft transponder, which is permanently broadcasting the identification, the call sign, the altitude, the position, and all that. So something we are also doing, we are studying a solutions to restrict the data that is transmitted from the aircraft as well. Or we ensure that some data is transmitted, is used by air traffic control, but cannot be received by these home-based systems. Because today we can buy for 300 euros, we buy an ADS-B receiver, you know, in the electronics shop, and we implement that at home, and that's it. So that's what I can say about this web-based flight data providers. They are a problem, and they have a positive dimension, and they have they are a threat if we speak about sensitive flights, in fact.
Thank you, Jorge. I think it was clear. I already said in the chat, I thank you for the questions, and any other, Boban is thanking you actually, so I think you replied to his question well. And I said to everyone else that if they have any other questions, they may direct it to you. Is that okay, Jorge?
That's okay. You have my email address. So this slide,
we can see in the slides. Yes,
you can see. So we are permanently available here at EUROCONTROL to provide any support. We support all stakeholders in aviation stakeholders, and it's not only myself. So I have lots of colleagues that work in this domain. And sometimes if you have something very specific, I can point you to the right person, no problem.
Perfect. Thank you very much, Jorge. Now we'll continue with Goda also, because she is going to present also an opportunity in H2020 program, the Space Hubs Network, otherwise known as SUN. So we'll ask you also to continue with us and know more about this opportunity offered by the European Commission. Goda, you may take the floor.
Thank you, Lena, and thank you, George, once again for the insightful presentation. Just to answer quickly a question that came up on the chat, whether it will be possible to rewatch the presentation. So yes, it will be available on our website, so you will have a chance to rewatch and maybe watch those parts that you have missed if you joined us a bit later. So I apologize for running a bit later our schedule, but I invite you to stay a bit more for like 3-4 minutes to listen more about the initiative that's behind this webinar and other opportunities that we offer to the startups in the space industry. So Space Apps Network is an initiative that is aiming to increase the commercialization of space-enabled solutions and encourage the growth of startups and scale-ups in the space industry. So we are a consortium of 7 experienced partners, experienced in space industry, but also running business acceleration programs and supporting businesses. So we will be running this project for 2 years in total. So it's actually almost a year since we've started our initiatives, but we still have opportunities ongoing and even more plans for the next year as well. So just to summarize how this idea actually came and why we are aiming to support businesses specifically in the space industry is that we think that although there is already a support network for space startups, not all startups have reached the required level to apply for specific programs. So what we want to do is to actually help those startups to reach the required level, to address the needs and the challenges you face specifically, and basically help you to apply to those programs, match you with the programs that are relevant to you. We also think that space industry is still an unknown area for some of the businesses. So for example, some SMEs that are looking to, let's say, go to that market, maybe are not aware of all the opportunities that it has. So our aim is to increase that awareness and talk about the opportunities and moreover support you in actually using those opportunities. So what we are aiming to do is actually we aim to fill the gaps between those support initiatives that I've already mentioned. So by working with each of the startups individually, we basically offer one-on-one mentorship program. We address your needs, we help you identify those needs and offer the support in that specific area. And we also organize the events, so for example, like this webinar, and also we have roadshow events and also hackathons where we specifically discuss the existing opportunities and also help you to solve those challenges in the space industry. So to tell you a bit more about the mentorship program that I have mentioned, so we do have 3 levels. So basically pre-incubation program, pre-acceleration, and also post-acceleration program aiming to help startups at different levels. So as well as like early stage teams that aren't necessarily like startups already and don't have a legal entity, but entrepreneurs who have the idea, or researchers who are doing some research on and actually developing the idea that could help other companies, but don't necessarily have the skills or the knowledge on the, let's say, business model. We do help early stage startups and entrepreneurs, but also those who are already in the industry and, for example, are looking for initial investment or are struggling a bit with onboarding clients. So we do offer support in those areas. So the focus is a bit different for each of the programs. So for example, for pre-incubation, actually, this is more on like prototyping the MVP, as I mentioned, finding the revenue model and basically defining the business model. Pre-acceleration program is, again, focusing on the MVP, but more like validating the value delivery, finding out more about the market. And post-acceleration is more for those startups who are more experienced, let's say, have their market already defined, they know their market, but they are looking to attract investment. So we are looking for 80 startups in total to participate in our program. So 40 for pre-incubation, 30 for pre-acceleration, and also 10 teams to participate in the post-acceleration program. So we already have some of the teams that have started the program since September, but actually the opportunity is still there for you to join. We still have spaces available for the next year. And we are offering in these programs 12 to 24 hours of support, depending on which program you join. And the good thing as well is for those who start our, let's say, early stage program, so you can actually go through all 3 different levels. So it means if you are early stage startup that is looking to join the pre-incubation program, once you have finished that, those 12 hours, you can still join our program, so you receive even more support to develop your idea. So as I mentioned, the opportunity is still there. We have actually extended our open call, so you can still apply up until the 22nd of December. So basically before 5 p.m. CET, you can fill in your application at our website, which is spacehubs.network. So if you are looking to further develop your idea, improve your investment readiness, and maybe you are looking to join other space programs and you just need some help with the application and you want to improve some specific areas, and Space Hubs is there for you. We are looking to help you and to assign mentors both in, let's say, technical area and also business development area to help you reach your goals. So at the moment, just to summarize and repeat, we do have 3 different programs. So on the website, you can actually find a tool that will help you to identify which program will best suit your needs. But we are, of course, there to answer your questions. So if you have any doubts, then feel free to message us or email us on the platform, or just by reaching us on the email address, so we can help you identify which level is best for you and also answer any questions you have about the program. We do have more than 30 mentors who have already joined our network. So it's a really wide network of experts in different areas, as I mentioned, maybe those who specialize specifically in the space industry and can help you with some technical questions, but also those who are specialists in other areas. So more like on the business development, for example, experts in sales, and those who can even help you prepare your pitch as well. And we offer 12 to 24 hours of support. So the programs are of different length, of different durations, over 3 months to 6 months. And what I want to emphasize on as well is that they are fully flexible. So we do help you to identify the needs and we do address them individually. So that means that one mentor is specifically working with just one team. So we just go at your pace, and also the sessions are flexible as well, meaning that you do communicate with your mentor and make a decision on when to arrange a session. So you don't have specific days when you have to be there. We know that all startups are busy developing their ideas, so we do want to offer that flexibility for you to arrange the sessions in advance and work according to your schedule. So yeah, just a reminder that opportunity is there. So please apply. The application process is not long. We do want to tell us a bit more about your company, about your team, and who's behind the idea. So please fill the application. If you have any questions, reach out to us and we can definitely help you. And I'm also leaving my contacts here as well. So in case you want to get in touch, you can find me on LinkedIn and also reach me by this email address, but also please visit our social media and our website as well for more information about the program and contact details as well. So thank you, everyone. And back to Lina.
Back to me. Thank you, Goda. If you have any questions, as we already late, I would maybe accept one question, and then all the others can be made directly through the Space Hubs network website. If there are any questions, we still can accommodate one. If not, we'll be closing it now, as we have surpassed a bit of the defined time. But I think it was very worth it. We hope you felt the same. As Goda was saying, we extended to 22 of December our open call. So you still have time to go to our website and still know how can you use this opportunity. So please do. As I said, we are on Twitter, we are on LinkedIn. So please follow us up to know about our next webinars, our events. We're having hackathons and roadshows coming up. So a lot of news, and we hope to count on your participation and to spread it to your network. So for now, I see that we don't have any other questions. Please just check and see the website. And if it comes up any other question, let us know. Thank you very much and have a great day. Thank you, Jorge. Thank you, Goda. Thank you all.